You may be wondering what makes up everything around you. Well, you probably know what it is, since every science teacher ever told you in the first grade. It's called an atom. Atoms are very small. If you were to take a golf ball and grow it to the size of the Earth, a single hydrogen atom would be a bit smaller than a common house cat, which makes the hydrogen atom approximately 36 centimeters. And the average adult, which is 1.77 meters, would be about 3.8 times larger than the Sun. Isn't this a seismic difference?
But what is an atom? An atom is a form of matter that cannot be broken down to anything simpler, unless you do the process of nuclear fission where you shoot a neutron at an atom, like uranium, and it splits the atom's nucleus into smaller parts, releasing a huge amount of energy. Atoms also have their very own parts, which are called subatomic particles. These are the proton, neutron, and electron. There are actually many more subatomic particles, and even the subatomic particles are made up of the elementary particles, such as leptons, quarks, and bosons. But we won't be covering those in this video.
Protons are the positively charged subatomic particles found in the nucleus of the atom. Neutrons, on the other hand, are neutrally charged particles found in the nucleus. Electrons are the negatively charged particles found in the atom, or more specifically, an orbital. In the example, this would be the nucleus and this would be the orbital. Both the proton and the neutron have much more mass than the electron. This would mean that most of the mass would be found in the nucleus. Isotopes are elements that have the same number of protons, however, it has a different number of neutrons. Furthermore, the elements are also defined by the number of protons in the atomic nucleus. For instance, an atom with 6 protons must be carbon, and an atom with 92 protons must be uranium. And if you were to take away 1 proton from carbon, it would no longer be a carbon atom. You can refer to the periodic table to know the atomic mass, chemical symbol, and atomic number. The atomic number is the number of protons the element has. So an isotope will have a different atomic mass than normal. If it has a lower atomic mass, then there are less neutrons, and if it is higher, then there are more neutrons. Physical properties of any isotope will depend on the mass. However, some isotopes are radioactive, such as tritium. This is a hydrogen atom that has 2 neutrons, but normally, hydrogen has no neutrons. What can be worse is that some of these radioactive isotopes are natural. An ion is an atom or a group of atoms that have a net positive or negative charge. There are 2 types of ions, which are the cations and anions. A cation is an ion that is positively charged. This occurs when a neutrally charged atom loses 1 or more electrons. On the other hand, an ion is an ion that is negatively charged. For this to occur, a neutrally charged atom has to gain 1 or more electron. Their properties pertain to the following: electrostatic forces of attraction between the oppositely charged ions, high melting and boiling points, and conductive when liquid for ionic compounds.
A compound is when 2 or more elements are bonded together, either through a covalent or ionic bond. A covalent bond is where a compound shares electrons, and an ionic bond is a bond between 2 ions. Compounds can be separated chemically. Although the same does not apply to mixtures or anything as such, since the chemicals are not chemically bonded together. Compounds are also presented through ratios. For example, table salt is composed of sodium and chlorine, and the ratio of sodium ions to chlorine atoms is 1 to 1.
Studies of matter have advancements of technology so far that we are able to create cars or any other apparatus that reduce greenhouse gases. It helps with the solutions of the worldwide problems such as the greenhouse gas problem. It also helps with the reduction of consumption of fossil fuels thanks to things such as electric cars. Better alternatives to harness juice from the earth using windmills, hydraulic energy, and others. These advancements help pave the way to a better environment for humankind.